Let's look at vertical transformations, also known as a vertical shift. Um, and also just point out this is a rigid vertical movement. So what are we trying to do? What occurs to the function f of x when we transform it by adding and subtracting a constant? That is, we're going to look at y equals fx plus d or subtract fx minus d. What does that do to f of x? Now, another thing to remind ourselves, what does rigid movement mean? Rigid movement means the object changes position without deforming. So for example, here we have a earplug, and if I just tap it, it's moving, but the shape of the earplug stays exactly the same. I'm just moving it across a piece of paper. So right now there is movement. So vertical movement, all that's going to mean is that if I start here, it's just going to move either up or down. That's really what we're doing. So consider, for example, the graph f of x equals absolute value of x, another function. And we see the graph of that is right here. So it's one of your basic functions. What is the graph of g of x? And why am I saying now, where's g of x coming from? Because I'm going to alter the function f of x by adding 3. All right, so one thing that to get the intuition of this, we should start to write down some order pairs that are associated with this graph. So for example, one order pair I see, and this is of course a very simple function, but that's why we chose it, because it's nice and simple. For example, I see that at -2, the y value is 2. At 0, it's 0, and this thing is symmetric across the y-axis, so at 2, it is 2. So now what does this say to do? Well, let's think about what this table really is saying. When I enter -2 into this function, what do I get back out? 2. But what is this g of x saying to do? It says after you do that, add 3. So really what it's going to look like is the following. Here is the 3 inputs. And what am I really doing? To the y value, I'm just going to add 3. Okay, so this is the y value. F of x is the y value. I got to remember y is always associated with a range if we don't alter that convention. So all I'm going to do is come over here and says, okay, at -2, I get 2. And afterwards, I'm going to add 3. So this gives me a 5. At 0, I get 0, right? When I enter 0 here, I get this function punches out a 0. But then what am I going to do? I'm going to add 3. So 0 plus 3 is 3. Last, I enter 2. And I get the function output is 2. And what am I going to do afterwards? Add 3. So that gives me, again, 5. So if I were to graph this, I would get the following. -2 is 5. So let me follow it up. -2, I get 5. At 0, I get 3 right here. And at 2, I get 5. It's right here. So at 2, I get 5. So what has happened? Okay, I'm going to draw the best I can. It looks like the graph has moved up 3 units. Now, I believe this topic here is one that you can play around with. So I would encourage you to go, for example, to something like Desmos. And let me recreate what I just did this on a piece of paper. I'm going to enter f of x, and then I'm going to enter the absolute value of that. And the absolute value in computer science is abbreviated ABS for absolute value, and then x. So when I do that, notice the computer immediately recognizes what this is. The computer told me to drag it to another screen to share, so I think it's not sharing. But anyway, I want you to open up my OpenMath and enter this. Okay. Now, what have I done? If you look closely, the one thing about Desmo is that this is very symbolic, so you should play with different functions and see what happens. So there's my f of x, but if I enter plus 3, it gives me the result that I just figured out. And notice it matches beautifully. So what has happened? It looks like I have just shifted up 3 units. 1, 2, 3. All the points are being shifted up 1 unit. So let's look at another one right here. Consider the function square root of x. What is the graph of h of x, which equals f of x minus 5? So we'll notice right now, by the way, when we write something like this, we say that now h of, and please remember this statement because it appears, it's a way of communicating. It's part of the function notation that we were supposed to know something about. H of x is written in terms of f of x. In other words, I'm writing h of x and it equals, and then all of a sudden the way this is going to be defined, it uses f of x in its explanation. And that's what h of x is written in the terms of f of x, in terms of meaning we're going to use f of x to describe h of x. Great. So what's happening here? Well, again, let me create a little table with some order pairs are clearly visible. So one that's clearly visible is 0, 0. Another one here that's pretty clearly visible is 4. 4, I get 2 back out. And another one is pretty, might be clearly visible. Actually, it's not very visible here. Yeah, it's just missing, but that's all I know 2 right now. It's okay. We'll go with those 2. So now what are we doing here? Again, the y is my f of x. What this has to do now is after you enter and get this output, subtract 5. So now this h of x, what is it doing? Well, it's taking the y and subtracting 5 from it. So I'm going to take every single y, subtract 5 from it. So I enter 0, this thing produces 0, but then I subtract 5, and I get negative 5. Enter 4, this thing pumps out 2, and then the next thing it does is subtract 5. So when I subtract 5, it gives me negative 3. Okay. So I come down here, and I should have given myself a little more room. I just did not. Okay, I'm going to pretend for a moment that this is negative 5. I know it's not. So 0 goes down all the way to negative 5 right here. And what about 4? It goes down to negative 3. Just sitting right here. So actually, I should have not done this. Let's see how far I could go. It really should be down here somewhere, approximately. That's where the negative 5 is most likely located. Anyway, so now I redraw my graph. And the idea is I'm going to get the same looking picture, but shifted down vertically. 5 units. So what have I done? All I'm doing is changing the y's by subtracting 5 from it. So that's the result of taking this function and subtracting 5 from it. The picture stays exactly the same, except it's been vertically shifted down 5 units. So again, let's come over here, share my screen, I hope. And I want to enter, again, the square root function is sqrt, and this pops up. So there's my basic. What am I doing now? I'm going to come over here and subtract subtract, no, subtract 5. And there is my new function. There is 4 right here. And now I went down all the way to -3 down here. All right, so if I come over here and just type y equals -3, so we can clearly see that. And then the other one was y at 4, I get 2. So, and all what's happening again is that 0.42 has gone down by 5 units. 1, 2, 3, 4, 5. All right, so if I had to then use what information I've just picked up on, let's kind of think about this for a second before I tackle example 4. Given the function f of x, the function of g of x equals f of x plus d, where d is greater than 0, is the function of f of x. Okay, right now, so this thing I'm adding is positive. It's transformed by moving the function f of x d units upward. Given the function f of x, the function g of x, f of x, g of x equals f of x minus d, where again, d is greater than 0, so it's positive, so I'm subtracting a positive number, is the function of f of x transformed by moving the function f of x d units downward. And again, if you forget, remember, you can play with this in decimals to make sure you understand how this works. So now let's go to example 4. What is the equation of the following function depicted in the graph? Well, what I'm hoping for is 1, recognize this is quadratic. In other words, what I'm looking at, I am looking at a parabola. The graph, again, of a quadratic is called a parabola. 2, I recognize that the base, it's a transform basic function y equals x squared. And then how can I make sure there's nothing weird going on? Let me just check a couple things. Here is this point. If I go 1 unit over, I get a shift of 1 unit up, shift over 1 unit to the left. Oh, there's a 1. Sorry, that's not a 1 right there. The 1 is located right there. And indeed, if I go 1 unit up, I get get right here. There's a 5. There's the 1 unit. I'm just looking at the wrong spot. So 1 unit to the right. This is 2. Okay, great. Every 2 of these is 1. So I got 4, 5, again, 2 units. Gives me the next one. I move up 2, just like what a quadratic would be. In other words, enter 1. 1 squared is a 1, movement of 1. So it looks like this is a rigid movement up of this equation. Again, remind myself one more time, this is what I'm trying to do. Maybe I'm not doing a great job. But when I look at this function, 0, entering 0 into this gives me 0. Entering 1 into this gives me 1. And -1 also gives me a 1. And I found these right here, but what's happened it looks like this thing has been shifted upward 4 units. So if I want to find the equation of this function, all I have to do is remember that this new function, as a matter of fact, let me call it something else entirely different. This m of x is really this old one. Let's say this is f of x, but all I've done is added 4. So when I look at the equation, it's going to be just x squared plus 4. And that is really very nice. If I can recognize what this graph is, I can immediately write the equation just by understanding what the basic function looks like. And so again, it's very simple without doing a lot of work. Also notice that when I added 4, and just to verify that I'm doing this right, if I enter 0, what this new function says is add 4. So let's just check. If at 0, I add 4, I get 4. That's great. At 1, if I enter it into this function, 1 squared is 1, plus 4 is 5. And indeed, at 1, I get 5. So it's working.